All right, so standard form of a quadratic function is kind of where we always start. Do you guys know what standard form is? Of a quadratic. You should know. Starts with an A. That a squared plus b squared equals c squared. That's Pythagorean theorem. So ax squared plus, there it is. And it should equal 0. Good. There's your standard form. We always want it written that way. And do you know what the graph is called if you graph a quadratic? Or do you even know what it looks like? Martin? Good. It could look like a U, or it could be flipped the other way, like an upside down U. Do anybody know what that's called? Say it again. Parabola. Good. A parabola. Thinking about spelling it, in my head I always say parabola. That's how you kind of remember to spell it. Don't call it a parabola. Don't do that. Yeah. Sorry, my O and my L got close together. Parabola. Yeah, parabola. So the path of any object flying through the air can be described as parabolic. Hence the Angry Birds theme for this set of notes. Think about Angry Birds flying through the air. They are making a very kind of stretched out parabola, right? So anything you throw, pick up a baseball, chuck it, that's going to make a parabola, right? It's going to go up a little bit and it's going to come back down. Pick up your baby brother, throw him across the room, parabola, right? So mom looks at you like, what are you doing? Making parabolas. Don't tell her I said that. Trying to help you out. If you ever get in trouble, just making parabolas, Mom. Just seeing how that works. All right, so let's just get real quick some practice. I know we've done this quite a bit in the last chapter. Put the equation in standard form and name A, B, and C for me. So what about number 1? What order should that be written in? Good. So 2x squared plus x minus 11, making sure it's your x squared, then your x, then your number. The order it has to be in when we're factoring anyway. So what would your A value be? Just 2. A is the number in front of your x squared, okay? And then your B and C. Good. All right, number 2. What order should that one be written in? Good. So what's your A? B? And your C? 0. Good. If there's nothing there, it's just a 0. And then number 3. Do I have to change anything? What's that f of x sitting in front of there? These ones had y's. What's f parenthesis x? What's that? It's just another way to say y equals. Yeah, it's just a name, right? Like his name's Frank, right? So don't get kind of up in arms. So just using a different notation. So what's your A value? 2/3. B? 0. And C? 0. All right. That should be pretty familiar, right? Just kind of warming you guys up this morning. All right, so what does standard form tell us about the parabola? I can tell some things about what the graph looks like just by looking at the equation. Okay, so the point where the parabola changes directions is called what? Right, because if you're thinking about it, like it's going to come down and then eventually it's going to stop and kind of come back up again. What's that point called where it changes? It's no longer going down, but now it's going up. Starts with a V. Vertex, good. That is called your vertex. Which way does it open if A is positive? What do you think? Positives means it should probably open up. Yeah. It opens up if A is positive. So if you look down here, I kind of got a graph here. If I have a positive x squared, my A value is a positive 1, right? It's going to open up, right? It's pointing up. What kind of vertex is that? Is that going to be the highest point on the graph or the lowest point on the graph? The lowest, meaning it's going to be its minimum point. It's kind of backwards when you think about it, right? Because you're like, if it's positive and it's opening up, but you got to stop and think what that graph looks like. So that means the vertex is actually the lowest point, it's the minimum point. And it opens which way if A is negative? It's going to open down. So you can look at the graph over there. All right, it's going to be pointing down. And the vertex then is its maximum point, the highest point. Now, if we had more time in the semester, because I have such a short time with you guys, I used to when I taught in Finley, whenever we talked about all this kind of stuff and graphing, and we did a lot with it, like bringing in like the story problems and real life scenarios, and we just don't have a lot of time for that in here. But I love things like this because it always talks about like your profit margin. Like if you're going to write equations for like the profit for like the product you're creating and selling and whatnot, wherever that vertex is going to be the highest profit you could possibly make. So like stuff like this is very relative when you're talking like money, business world, like I want to make a profit. All right, so decide whether the parabola will open up or down and whether it will have a maximum or a minimum point. So again, I'm not even graphing, just looking at the equation. So number 4, my A value, is it positive or negative? Positive, right? That A value, so A is positive. So will it open up or down? Good. It's going to open up, right? It's going to look like that. So its vertex is going to be its maximum or minimum? Minimum. It's the lowest point, right? That vertex is going to be like right down there. The lowest point on your graph. All right, number 5, is your A positive or negative? It's positive. It's in the wrong order, but there it is. So A is positive, which means it's going to open up. And the vertex is going to be the minimum. Number 6, my A value is negative. Good, it's written in the wrong order. There it is. So A is negative, so it's going to open down. Looks like that. So that means the vertex is the maximum. So anytime you're graphing, this is just a nice kind of mental check. Like you plotted the point, you graphed the whole thing, and you're like, is that really going the right way? Double check, okay? All right, so first kind of step for graphing, kind of baby step through this, you have to find the vertex, right? Because what do you know about parabolas? What do I know about this side of the parabola versus this side? For the same kind of, same but different. Wait, what does she mean by that? Do you guys ever do that art project when you were a kid where like you put paint on one side of the paper and then you fold it in half while the paint's still wet and then open it up? I used to love doing those in art class when I was little, right? Because this side looks just like this side, except it was the mirror image, right? It was reflected over it. So that's called symmetry, right? This side is the same as this side. It's reflected over that. So the same thing's going to happen here. So if I know where the vertex is, it's almost like that fold line in my paint project. It's going to tell me where this side kind of stops, and then this one kind of mirrors it on this side, okay? So to find the vertex, to find the x-coordinates, right, because the vertex is going to be an ordered pair, the x-coordinate is negative b over 2a. Does that sound eerily familiar? Yeah. It's almost like they took the quadratic formula and kind of broke that thing into pieces, right? We talked about the discriminant, which was the part underneath my radical that helped me tell if something factored or not. And now I have the parts not in the radical, the negative b and the 2a, and now those are going to help me to find the vertex, which is kind of cool. It all kind of works together. All right, so to find just the x-coordinate where it is, that's what we're going to do. And then to find the y-coordinate right here, you take this answer and you just plug it back into the equation. So let's go ahead and try one over here. To find the x value, we do negative b over 2a. So what's negative b? It's going to be negative 8 over 2 times my a value is 2. So that's negative 8 over 4, which is, there was a big pause there, guys. Hard math today, negative 8 divided by 4. That found me my x-coordinate, okay? And then to find the y, we're just plugging it back in. That's all we're doing. So I'm going to take, this is my x, I'm going to plug it in here, and I'm going to plug it in here. So 2 times, my x I said was negative 2 squared, plus 8 times 2, plus 5. Now, at this point, could you just grab your calculator and type that whole thing in? Yeah. If your basic math skills are not that great, grab your calculator. Let's figure it out right now, guys. See the wheels turning for some of you. You're like, I can do this in my head. Shouldn't be 27. It's all right. I'm going to wait till somebody tells me the right answer. I did it in my head. Nope, definitely didn't get -3. What? I got 29, yeah. If you're trying to do it in your head, because I know some of you were, you have to do exponents first. So what's -2 squared? It's +4 times 2, 8. 8 times 2 is 16. So 8 plus 16 is 24, plus 5 is 29. So if you're doing it in your head, you have to make sure you do order of operations correctly. Otherwise, you can just type the whole thing in at one shot. Hit enter. All right, so the vertex of this equation would be at -2 and then 29. So that is your vertex. Now that one probably wouldn't be so fun to graph because most graphs that we're looking at by hand don't usually go that far. Yeah, so the ones I'm going to give you to graph by hand, I'll try my best to keep that vertex on there. Yeah. Oh, I totally didn't put a negative in there, did I? Thank you. I was doing the math on that. No, thank you so much. I totally missed that negative. My apologies. You were right. So that's going to give me 8. So that would be -8 plus 5 is -3. You're right. Thank you. Totally lost the negative sign. So, negative sign doesn't make a big difference in your answer? Yeah. Sorry. Thank you. All right. But process-wise, even if you forget a negative, are we okay? Sorry about that. All right. So let's go ahead and get some more practice just finding the vertex. We're not even graphing yet. Again, baby stepping into this. So the vertex on number 7, we start with -b over 2a. So -b is going to be -4 over 2 times a, and a is 2. So -4 over 4, which is -1. Now, those of you who are really calculator dependent, because I know some of you are, when you're typing in this, if you're up here at the -b over 2a, do you notice every time I do this, I always clean up that bottom number first? So if you would just type in like -4 divided by 2 times 2, like you can't just type that in as one big division. If you typed it in as a fraction, you'd be okay. But just, I honestly think it's easier to just kind of clean up the bottom and then just do the math together. Okay. All right. Once I have -1, we're going to come back and we're going to plug that in everywhere we see an x. So we have 2 times -1 squared plus 4 times -1. I won't lose my negative that time. And then -7. Good. -9 is correct. So again, that is your vertex. That's that changing point. Now, if I would graph that, which we'll do in a minute, what should it look like? Does it open up? Does it open down? Number 7? Would it open up or open down? It would open up because your a value is positive, right? So that vertex, -1, -9, will be the lowest point on my graph. And then from there, it would just open up. All right, number 8. So again, always going with -b over 2a. So -b, +6, good, over 2 times, my a value is 1. So 6 over 2, which is 3. So that's the x part of my vertex. All right, so from there, we're going to go back. Anywhere you see an x, we're going to plug that in. So we have 3 squared minus 6 times 3 plus 5. What do we get? we put my mental math versus your guys' calculators? -4, good. Seen a doctor yet for those hiccups? Good. Not just for the hiccups, is it? Okay. But you're going to ask? Okay. Worried about you. All right. What about number 9? So we're going to go negative b over 2a. What's negative b? It's just 0. Please don't write -0. Just 0. Over 2 times a, so 2 times 3. And 0 divided by 6 is 0. Once you know x, we're going to go back, plug that in anywhere you see an x. So 3 times 0 squared minus 4 equals -4. Good. That moment of, I don't know. 0 squared is just 0, times 3 is 0, minus 4 is -4. All right, let me give you guys a minute. Go ahead and try number 10 on your own. Be careful it's not written in the right order. All right, guys, let's go through number 10 and see what happened. I saw some kind of different things going on. So starting out, negative b over 2a. Negative b is going to give you positive 3. 2 times my a value is -1. So I'm going to have 3 over -2, which just -3 over 2. It's fine, or doesn't matter. So there's my x value. So to find the y value, we got to plug that back in. So anywhere you see that x is where that goes. So 1 minus 3 times a -3 over 2 minus, now be careful here, a lot of people lose that negative when you're sitting with another negative next to it. If it's already there in the problem, make sure you don't lose it down here, okay? So -3 over 2 squared. And I'm going to be honest with you, I don't want to do that much mental math this morning. It's a lot of fractions. All right, so 1 minus 3 times -3 over 2 minus -3 over 2 squared. And we get 3 1/4. Grace, yours was right. Those of you who did not get 3 1/4, go back and double check. Did you lose that minus sign in front of that squared one? A lot of times people lose that. Questions, guys? Doing all right? Yeah? All right, ready to put it all together? Let's take a look at graphing. Let's go back old school, which you probably would have done, I'm guessing, 7th grade, 8th grade maybe, making a table. What did you typically plug into those tables? Okay, 1, 2, but I also probably wanted to look at negatives. So I don't know about you guys, I just remember in school it was always like -2, -1, 0, 1, 2. It was always, let's see what's going on in the negatives, let's see what's going on in the positives, and kind of figure out what's going on with the graph. Okay, so let's go ahead and just plug this stuff in, see what happens. So if I would plug this in for x, right, what is -2 squared? It's 4. -1 squared. 0 squared. 1 squared. 2 squared. All right, mental math is working there. All right, and then we'd plot our points. So -2, 4. So I'm going to go back 2 and up 4. -1, 1. So back 1, up 1. 0, 0. 1, 1. So over and up. And then 2, 4. You will learn I am like the worst person for drawing lines, drawing graphs. Sometimes I miss my dots entirely. Sorry. All right, so we have a nice parabola, right? Did we know it was going to open up? Yeah, we knew that. Now, that one worked out nice. I found my vertex. But is the vertex always going to kind of show up that easily for us? No, right? It's not always that pretty right in the middle, just like that one is. So what we want to do is start with our vertex, which is why we kind of practice finding that. Then after we know the vertex, we can kind of pick points to plug into our table. so that we can actually graph that line. Now, granted, I can plug any numbers I want in for any single problem. It does not matter. It will be part of its graph. But I may plug in 5 points, and it's part of here. And really, my vertex comes all the way down here and goes up. Right? If I just find them up here, that doesn't tell me what the graph looks like. But if I know the vertex is here, I'm going to do that one first, and then I should pick points that are near the vertex. Right? That way I can find other points. Now, we talked about that it's symmetrical, right? This side looks like this side. So I'm a lazy mathematician, right? If I can find the vertex and I can find 2 points over here, do I really have to do the math to find these points? No. Because if you think about it, my vertex is kind of that fold line, right? We talked about the art project. This one is 1 space away from that fold line, so the other side's 1 space away. This one is 2 spaces away from the fold, so that one on that side's 2 spaces away. So if I can find just 2 on the one side of my vertex, I can save myself some math and just reflect them on the other side. It's okay to be lazy sometimes if you know that's how it works. So just a reminder, finding our vertex is going to be over 2a. Let's go ahead and try it. So if I asked you to graph y equals 2x squared minus 8x plus 6. Okay, first thing we want to do is find that vertex again. So negative b over 2a. Negative b is 8 over 2 times a. So 2 times 2. So it's going to be 8 over 4, which is 2. Again, that is the x part. How do I find the y? Plug it back in. So anywhere up here I see an x, that's where I'm plugging in the 2. So 2 times 2 squared minus 8 times 2 plus 6. Negative what, 2? Negative 2. All right, so that's my first point. So I'm going to plot 2, negative 2. So over 2 and then down 2. Again, this is kind of my fold line on that art project. Thanks. All right, so then when I go to make a table of values, again, I can plug anything I want into my graph. However, I want to make sure I pick points that are kind of near my vertex. It's the best chance I have of keeping it on the graph, too. All right, so right now, here's kind of my trick. My x value on that vertex was a 2. So I'm going to go ahead and pick 3 and 4 for my table. Since the vertex had an x value of 2, I want to go as close to it as I can. I'm going to go 3, 4. Could I have went like 1, 0? Sure. I just have a tendency I always just kind of go to the right. So I pick the 2 numbers right to the right of that. So if I plug in a 3, what do we get? Three squared is 9, 18. Yeah, I got 0. Double check, guys, because if we have trouble just typing stuff in, I don't want that to be the problem, okay? We need to figure that out now. And then if I plug in a 4, you get 6? I'm trusting her. All right, so I can plot the point 3, 0, which is going to be right on the axis. So if I plotted that 3, 0, do you see how it's 1 space away from my fold line? So that means I know there's another one on 1 space on the other side of it. And then I can plot 4, 6. And that's 2 spaces away from the fold. So I'm going to have 1, 2 spaces away on the other side. Just do me a favor, when you're drawing these, should there be a point where that vertex is? Like a sharp point in your graph? No, it's curved, right? It comes down and then kind of gradually just touches it and goes back up. And I know it's hard. Graphing by hand is not always an exact science, but just do your best to try not to make that pointed. Pointed graphs come from absolute values, not from parabolas. How are we feeling, guys? We doing okay? No? Yeah? Maybe? Try another one? All right, let's look at the next one. So negative 4x squared plus 8x plus 2. All right, so first thing, let's find the vertex. So let's do the negative b over 2a. Negative b is going to make negative 8 over 2 times a, and a is negative 4. So that makes negative 8 over negative 8, which is positive 1. So that is my x value. To find the y, we're going to take that and we're going to plug it in anywhere we see an x. So negative 4 times 1 squared plus 8 times 1 plus 2. You don't have to write it out. I just Joe came in late. I wanted to know where I'm pulling stuff from. So what do we get then? We get 6. Good. So again, this number I just found, this ordered pair, this is my vertex. So I'm going to plot the vertex, which is over 1 up 6. And again, I like to make that line just so it's easy for me to see when I reflect. So it's kind of like that fold line. Art project, right? Paint on one side, fold it in half. You know, we're going to have that mirror image. All right. Then we get to make an XY table. I need to plug at least 2 numbers in just to kind of get an idea what's going on. Since my vertex had an x value of 1, what would I plug in here? 2 and 3. So if you plug in a 2, is it 2? We get 2. And then plug in a 3. Negative 10. That's what I got, but it's early morning, so just want to double check. All right, so let's plot the point 2, 2. And then again, I'm going to reflect it. That's 1 space away from that fold line, so I'm going to have 1 point on the other side. And then we're going to plot 3, negative 10. That's 2 spaces away, so I'm going to go 2 spaces on the other side. And that is a really skinny one. But again, notice your A value was negative, so it opened down, just like it should have. Questions so far? Anyone not sure where I'm kind of pulling numbers from? All right, so you guys try the next one on your own. Y equals negative 2x squared plus 1. So start with the vertex and then go from there. All right, let's go through it real quick. So we have negative b over 2a for my vertex. My b value is actually 0, there isn't one, over 2 times a. So I get 0 over negative 4, which is just 0. That is your x value. We're going to plug it in for x. So negative 2 times 0 squared plus 1 is just 1. So that is my vertex. So 0, 1, it's just going to be up 1 right there. So that fold line is just right on that y-axis. All right, then we have to make our xy table. To figure out, again, the numbers I'm plugging in here, I'm looking at whatever this x value is, and I'm just going 2 numbers to the right. So that's a 0, so I'm going to go 1, 2. If that number had been a 7, I'd go 8, 9. Okay, so just whatever that x value is, that's where I'm picking my x's from here. So if I plug in a 1, what do we get? Negative 1. If I plug in a 2, all right, so we plot 1, negative 1. And that is 1 space away. So I'm going to go 1 space on the other side. And then 2, negative 7. That's 2 spots away. I got 2 spots on the other side. Now, I saw a couple people actually had 4 numbers in their table. And that's okay. If you want to write them down, you could go, I went 2 to the right, and you could also go 2 to the left, the negative 1, negative 2. But I'd find those points that I just reflected. Okay? All Again, I'm a lazy mathematician. If I can do less math, I'll do less math. All right. So how is that graph related to the answers that we get? Does anybody know? Say that again. Okay, how does that relate to what if I would just solve it? All right, last chapter we worked on factoring, square root method, quadratic formula. Like, I got answers. How's a graph relate to that? We'll find out. All right, so let's go ahead and graph this one. So again, start negative b over 2a. Negative b is negative 2 over 2 times a, which is 1. So negative 2 over 2 is negative 1. So then we're going to plug that x value back in here. So we'll have negative 1 squared plus 2 times negative 1 minus 8. And what do we get? Negative 9. All right, then we'll make our xy table. Oop, I can go ahead and plot this. Negative 1, negative 9 is way down here. Got a little fold line going. So since, again, this x value is negative 1, I'm going to go with which numbers? I go 0 and 1. Think of a number line. If I'm at negative 1, the next one over is 0, and the next one is 1. Okay, so plugging in a 0, we get what do you get when you plug in a 0?
I don't even know it.
Sophomores. Sorry to my 2 sophomores in here. I don't lump you in that boat. All right, what do we get when we plug in a 0? Good, we get negative 8. And if I plug in a 1, negative 5, thank you. You know, just for sake of what I got going on here, plug in a 2 for me. I want to go one more point on this. What do you get when you plug in a 2? What? 0. Good. Wow. Thought maybe you guys fell asleep on me there. All right. So let's go ahead and plot these points and reflect them. So 0, negative 8. And reflect it, right? It's 1 away, so I'm going to go 1 away on the other side. 1, negative 5. That's 2 away, so I'm going to go 2 on the other side of it. And then 2, 0. That's 3 spaces away from my fold line, so I'm going to go 3 on the other side. All right, and the connection we're going to make right here is going to help you so much in the next chapter, okay? So now let's actually solve that, okay? So I graphed it, great. Let's solve it and see what happens. So to solve it, instead of having a y, we're just going to replace that with 0. So 0 equals x squared plus 2x minus 8. And let's solve that. So what method do you want to use to solve? Factor? Sure, I'd probably factor that. So 2 sets of parentheses. Last one's negative, so my signs are plus minus. Options for A. So 1 and 1, so x and x. Options for C, you want to go 1 and 8 or 2 and 4? 4 and 2, thank you for putting that in the right order. All right, so there it is factored. And then if I asked you to solve, what would x equal? Good, negative 4 and positive 2. Look at your graph. Now that you know x equals negative 4 and 2, those are the answers, how does that relate to the graph? X-axis, there it is. Yeah, guys, look at your x-axis. Where's this point? 2. Where's this point? -4. Ooh, x equals, that was terrible writing, -4. Wherever your graph crosses the x-axis, those are your answers. Cool. Right? Come on, that's kind of cool. No, James is rolling his eyes at me right now. I think that's cool, James. All right, so let's try another one. So graph y equals x squared minus 5. Okay, so let's graph it. Negative b over 2a. What's negative b? 0, good. Over 2 times a value is 1. So 0 divided by 2 is 0. All right, and then we plug that back in. So 0 squared minus 5 is -5. So 0, -5 is just down 5. And then that means my fold line is right on the axis. So for graphing, I would make a table next. What numbers would you suggest I put in for x? 1 and 2, good, because this is at 0, so 2 to the right of that would be at 1 and 2. So if I plug in a 1, we get -4. If I plug in a 2, -1. Go ahead and give me a 3. Plug in a 3 for me. You got what? 4, good. All right, so let's go ahead and plot these. 1, -4, and reflect. 2, -1, and reflect. And 3, 4, and reflect. Now, looking at where your graph crosses the x-axis, did it cross at a nice point? It crossed at 2 point something and -2 point something. Do you guys agree? Could it be 2.5? Maybe. Could it be 2 point something else? Maybe. We don't know for sure, right? Because it didn't cross nice and pretty like that last one. Well, let's go ahead and solve it. So x squared minus 5. So 0 equals x squared minus 5. What's your best option to solve that one? Square root method. Good, because there's no b term. So I'll just add the 5 to the other side. So x squared equals 5. And then we take the square root of both sides. So x equals plus or minus square root of 5. Wait a minute. What's the square root of 5? Favorite calculator. What's the square root of 5? So a positive 2.23 blah, 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 and a negative 2.23 blah, blah, blah. Look at your graph. Is that where it crossed? Roughly. I mean, graphing by hand is not an exact science, but yeah, so right in here, that's your positive radical 5. And right here where it crossed, that's negative radical 5. But again, that's where you're seeing that plus minus come into play. It is crossing at a positive radical 5 and a negative radical 5, crossing 2 points. No one else thinks this is way cool? You're finally seeing that connection where how these things work together. To me, that was always the coolest thing when it all works together. All right. So just a little bit of terminology for you guys. So the solutions to the quadratic equation are the points where the graph crosses the x-axis, right? Wherever it crosses. So these solutions are also called your x-intercepts. Probably have heard that term before. They are also known as your zeros. Why would they be called zeros? What's the y value at those points? It's 0. That's why. Or they're known as roots. So depending on the textbook that you're looking at, some of them call them x-intercepts, some call them zeros, some call them roots. It all just depends on who wrote the book. They can all be called different things. I'll be honest, for most of the time, I use the word zeros. So anytime like you hear me say, what are the zeros? I'm asking you, what are the answers? If I set that equal to 0 and solve it, what do you get? The zeros. What are the answers? Okay? All right, we're almost done, guys. Last one. So, or is this the last one or is there one after this? Is there one after? Oh, there's one after it. Sorry. All right, almost done. So, y equals 4x squared minus 8x minus 5. So if I graph it first, again, let's start with that vertex, negative b over 2a. Negative b, positive 8, over 2 times a, which is 4, which is 8 over 8, which is 1. So to find the y, we're going to go back in the equation. Wherever you see an x, we're going to plug in a 1. It's 4 times 1 squared minus 8 times 1 minus 5. Is that negative 9? All right, so that again is my vertex. So 1, negative 9. All right, so if I go to plot the other points, make our xy table. This had a vertex value of x of 1, so I'm going to plug in 2 and 3. Good. What do you get when you plug in a 2? Negative 5, thank you. And what about when you plug in a 3? Good. So 2, negative 5, and reflect it, and 3, 7, and reflect. Now those points are far away, so be careful when you're graphing this. Now, just so you guys make sure we're on the same page, why on the last 2 problems did I make you throw an extra point in for me, but this one I did not? It would be off the graph, but that's actually not why I threw another point on there last time. Did anybody catch why I threw another one on? Go back to the last couple problems. Yes, I wanted to go past the x-axis. Because otherwise, I didn't know how wide it went, right? I didn't know. So I just made sure I had points on below the x-axis and above it, just so I could kind of see what's going on with it. Can you tell where it's crossing? Somewhere between 0 and negative 1? Somewhere between 2 and 3? Not really sure. All right, so if we set it equal to 0 and solve, see if we can find those actual answers. So 0 equals 4x squared minus 8x minus 5. What method should we use to solve? You want to try to factor? Should we play around with it, or could we check something to see if it factors? Because there's a lot of numbers there. Remember, you can check your discriminant, right? B squared minus 4ac. That'd be negative 8 squared minus 4 times negative 5. So does it factor? What'd you get for discriminant? Yeah, I got 144. So will it factor? Yeah, that's perfect square. For that is 12. So it will factor. Okay, so let's factor it. Could you have used the quadratic formula if you wanted to? Yeah, you could. Not always my favorite, though. So what are your signs? Plus and minus. Options for A, oh, I got options. You want to go 1 and 4 or 2 and 2? 2 and 2? 2x, 2x. Nope. Why did I write that there? And then we have 1 and 5. That's 2x minus 10x. Ooh, my signs are right. Right? So it worked? All right, so then solve it for me. So what does x equal? Good, 5 over 2 and negative 1/2. Just so you guys know, at this point forward, I will not be writing the 2x plus 1 equals 0, 2x minus 5 equals 0, and solving them. I'm just going to do those in my head. If you still need to write them down, by all means, go ahead. But at this point, I hope we can start to kind of get to that point. So take a look real quick, though. What is 5 halves? What is it? It's 2.5. Take a look at my graph. 2.5 and negative half. Yeah, that's where it crossed. Now, the question always comes up, though. We don't always have nice answers. We don't always just have radicals, where I could see where radical 5 was, like 2 point something, right? What other type of answers do we have? We have I. What's it look like on a graph if you have an I for an answer? It's a negative under a radical. It's imaginary. What does that mean? Let's take a look at this one. All right, let's graph it first. So negative b over 2a, negative b, positive 12, 2 times a is negative 1. So 12 over negative 2, which is negative 6. All right, and we'll plug that back in. Now here's one of those times where we have to be very careful when we're plugging stuff in. Right, that negative x squared, that negative is already sitting there. It is still there. And then I'm plugging in negative 6 to be squared. Most times people lose that negative right there. Minus 12 times negative 6, minus 39. You got what? I got negative 3. It should. You and your calculator would probably have to figure out what negative 6 squared is, and then make that answer negative. You're going to have to type it in after the fact. Okay? Just the way your calculator works. All right, so again, this is my vertex. So negative 6, negative 3, so type in negative 6 squared. Okay, and make that negative now. And then minus 12 times negative 6. It equals. And then minus 39. There it is. All right, you just type through. All right, so then XY table. All right, this was negative 6. So I'm going to plug in what? Good, negative 5, negative 4. All right, so going back, again, be careful with that negative sitting out in front. So negative 5 squared. Then minus 12 times negative 5, minus 39. I got negative 4 as well. Then if I plug in a negative 4, you guys know you can go back through and just arrow through it and change numbers out, right? You guys not? Yeah, it makes it a lot easier. Negative 7. Poor Grace and hers can't do that. Should be negative 4 and then negative 7. All right, so let's plot this, guys. So we have negative 5, negative 4, and reflect. and then -4, -7. Where does it cross the x-axis? It doesn't. So I mean there's no answer? It's imaginary, yes. So anytime you're graphing something and it doesn't cross your x-axis, that means your answers are imaginary. All right, let's go ahead and solve it and see what those imaginary answers actually are. So if I know they're imaginary, what's the only option I have to solve this right now? Quadratic, because that's not going to, I can't use the square root because there's a b term, and I know it's not going to factor then because I know my answers are imaginary. So x equals -b, 12, plus or minus square root b squared, so -12 squared, minus 4 times -1 times -39, all over 2 times -1. So x equals 12 plus or minus the square root of -12, all over -2. Can I keep going with that answer? Yep, sure can. First of all, I see there's a negative under there, so I want to pop that I out. And then factor tree 2 and 6, 2 and 3. So 12 plus or minus, I got a pair of 2's that come out, so 2i left over 3, all over -2. And then all three numbers? Should I divide them just by 2? Probably -2, otherwise I'm going to leave a -1 sitting on the bottom. So I'll divide them all by -2. And that's all three numbers. So we get -6 plus or minus I radical 3 all over 1, or just, I don't need that part. How cool is that? If it doesn't cross, that's when your answers are imaginary. Doesn't mean you don't have any, they're just imaginary answers. All right, questions on anything we did today? It was a lot. I know, today was a busy day. Tomorrow, we're going to focus on Graphing Calculator, how it can make your life a whole lot easier. Okay?